The National Electrical Code, specifically Article 334.15, allows NM cable to be bundled in parallel through holes in studs, joists, or rafters, and also along the surface of framing members. However, it's critical to understand the derating requirements that accompany this practice. When two or more NM cables are run through a single hole, the ampacity of the cables must be derated to 80% of their listed ampacity. If you have 4 or more NM cables passing through the same hole, the ampacity needs to be derated even further, down to 70%. Similarly, when NM cables are bundled along framing members, a derating factor of 80% applies to their ampacity. Now, let's consider installations involving steel studs. According to NEC Article 334.30, NM cable is generally not permitted to be installed within steel studs. However, there is an exception to this rule. NM cable can be installed through holes in steel studs, provided that it is protected by a sleeve or bushing. This protection is essential to prevent damage to the cable's insulation from the sharp edges of the steel. There are some additional considerations. NM cable bundle should be spaced apart to allow for proper heat dissipation. This spacing helps to prevent the cables from overheating, which can lead to insulation damage and potentially create a fire hazard. Derating is cumulative, meaning that if a cable is bundled through multiple holes or along multiple framing members, the ampacity of the cable will be derated to the lowest applicable percentage. It's also worth noting that the National Electrical Manufacturers Association, or NEMA, recommends a maximum of 3 NM cables bundled in a hole. While the NEC doesn't specifically limit the number of cables, following NEMA's recommendation is a good practice for maintaining safe and efficient electrical installations. Finally, NM cable bundles should always be securely fastened to framing members using appropriate staples, straps, or cable ties. This ensures that the cables are properly supported and protected from physical damage. To summarize, NM cable bundling is permitted through holes in framing members and along framing members, but it requires derating of the cable ampacity. Furthermore, NM cable is not permitted to be installed within steel studs without proper protection, such as a sleeve or bushing. To further elaborate on derating, it is a process of reducing the allowable ampacity of a conductor to compensate for conditions that reduce its heat dissipation capability. When conductors are bundled together, they generate more heat than if they were installed individually. This increased heat can cause the insulation of the conductors to degrade over time, potentially leading to a short circuit or fire. The NEC provides specific derating factors based on the number of current-carrying conductors in a raceway, cable, or bundle. These derating factors are applied to the allowable ampacity of the conductor as specified in NEC Table 310.15b16. It is crucial to consult this table to determine the appropriate ampacity for a given conductor size and insulation type. The ampacity of a conductor is determined by several factors, including the conductor material, size, insulation type, and ambient temperature. Copper conductors have a higher ampacity than aluminum conductors of the same size. The larger the conductor size, the higher the ampacity. Different insulation types have different temperature ratings, which affect the allowable ampacity. The higher the ambient temperature, the lower the ampacity. In addition to the number of conductors, other factors can also affect the need for derating. These factors include the presence of other heat-generating equipment, the type of raceway or cable, and the length of the run. If a raceway or cable is installed in a location where it is exposed to direct sunlight or high ambient temperatures, the ampacity of the conductors may need to be derated. Similarly, if a raceway or cable is installed in a long run, the voltage drop can reduce the available voltage at the end of the run, which can also necessitate derating. When installing NM cable through holes in steel studs, it is important to ensure that the holes are properly sized and that the cable is securely supported. The holes should be large enough to allow the cable to pass through without being pinched or damaged. The cable should be supported at intervals of not more than 4.5 feet and within 12 inches of each enclosure, box, or fitting. When using a sleeve or bushing to protect the cable, the sleeve or bushing should be listed for use with NM cable and should be properly installed. The sleeve or bushing should extend beyond the edge of the hole and should be securely fastened to the steel stud. It is also important to avoid overfilling the holes with cables. Overfilling the holes can restrict airflow and increase the temperature of the cables, which can lead to insulation damage. As a general rule, the total cross-sectional area of the cables in a hole should not exceed 40% of the cross-sectional area of the hole. When bundling NM cables along framing members, it is important to maintain adequate spacing between the cables to allow for heat dissipation. The NEC does not specify a minimum spacing requirement, but it is generally recommended to maintain a spacing of at least 1 cable diameter between the cables. The cable should be securely fastened to the framing members using appropriate staples, straps, or cable ties. The fastener should be installed in a manner that does not damage the cables. It is also important to avoid over-tightening the fasteners, as this can crush the cables and damage the insulation. When installing NM cable in attics or crawl spaces, it is important to protect the cable from physical damage. The cable should be run along the top of the framing members or through bored holes in the framing members. The cable should be supported at intervals of not more than 4.5 feet and within 12 inches of each enclosure, box, or fitting. In attics, the cable should be protected by running boards if it is installed within 7 feet of the floor or attic access opening. In crawl spaces, the cable should be protected by running boards if it is installed within 6 feet of the ground. When installing NM cable in damp or wet locations, it is important to use cable that is listed for use in those locations. NM cable that is listed for use in damp or wet locations is typically marked with the letters W or WP on the cable jacket. The cable should be installed in a manner that prevents water from entering the cable. This can be accomplished by using watertight fittings and by sealing the cable entry points. When installing NM cable in hazardous locations, it is important to follow the requirements of NEC Article 500 through 516. Hazardous locations are areas where flammable gases, vapors, or dust may be present. NM cable is not permitted to be installed in certain hazardous locations. In other hazardous locations, NM cable may be installed if it is installed in a raceway system that is approved for use in those locations. When installing NM cable near swimming pools, it is important to follow the requirements of NEC Article 680. NM cable is not permitted to be installed within certain distances of a swimming pool. In other areas near swimming pools, NM cable may be installed if it is installed in a raceway system that is approved for use in those locations. It is always a good idea to consult with a qualified electrician or electrical inspector if you have any questions about the proper installation of NM cable. They can help you ensure that the installation is safe and compliant with all applicable codes and regulations. Remember to always disconnect power before working on any electrical circuits. Working on live electrical circuits can be dangerous and can result in serious injury or death. Use appropriate personal protective equipment such as safety glasses and gloves when working on electrical circuits. Inspect all electrical equipment before use to ensure that it is in good working condition. Do not use any electrical equipment that is damaged or defective. Follow all safety precautions when working with electricity. Electricity can be dangerous if not handled properly. By following these safety tips, you can help prevent electrical accidents and injuries. The NEC is a comprehensive document that is updated every 3 years. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with your local building department to determine what codes and regulations are in effect in your area. By following the NEC and all applicable local codes and regulations, you can help ensure that your electrical installations are safe and compliant. This will help protect you, your family, and your property from electrical hazards. The ampacity of a conductor is the maximum amount of current that it can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor material, size, insulation type, and ambient temperature. Copper conductors have a higher ampacity than aluminum conductors of the same size. The larger the conductor size, the higher the ampacity. Different insulation types have different temperature ratings, which affect the allowable ampacity. The higher the ambient temperature, the lower the ampacity. The NEC provides tables that list the ampacity of conductors based on these factors. These tables can be found in NEC Article 310. It is important to consult these tables to determine the appropriate ampacity for a given conductor size and insulation type. When determining the ampacity of a conductor, it is also important to consider any derating factors that may apply. Derating factors are used to reduce the allowable ampacity of a conductor to compensate for conditions that reduce its heat dissipation capability. These factors include the number of current-carrying conductors in a raceway, cable, or bundle, the presence of other heat-generating equipment, the type of raceway or cable, and the length of the run. The NEC provides specific derating factors based on these factors. It is important to apply these derating factors to the ampacity of the conductor to ensure that it does not exceed its temperature rating. Overloading a conductor can cause it to overheat, which can lead to insulation damage, short circuits, and fires. It is therefore important to always select conductors with an ampacity that is sufficient for the load that they will be carrying. If you are unsure about the appropriate ampacity for a given conductor, it is always best to consult with a qualified electrician. They can help you determine the correct conductor size and insulation type for your application. In addition to ampacity, it is also important to consider the voltage drop in a circuit. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC provides guidelines for limiting voltage drop in electrical circuits. These guidelines can be found in NEC Article 210. It is important to follow these guidelines to ensure that the voltage drop in your circuit is within acceptable limits. The amount of voltage drop in a circuit depends on several factors, including the length of the conductor, the size of the conductor, the current flowing through the conductor, and the resistance of the conductor. The longer the conductor, the smaller the conductor, the higher the current, and the higher the resistance, the greater the voltage drop. You can use a voltage drop calculator to estimate the voltage drop in a circuit. There are many voltage drop calculators available online. To use a voltage drop calculator, you will need to know the length of the conductor, the size of the conductor, the current flowing through the conductor, and the resistance of the conductor. Once you have these values, you can enter them into the calculator to determine the voltage drop. If the voltage drop is too high, you can reduce it by increasing the size of the conductor, shortening the length of the conductor, or reducing the current flowing through the conductor. You can also use a voltage booster to increase the voltage at the end of the circuit. In summary, when designing and installing electrical systems, it is important to consider both ampacity and voltage drop. Ampacity is the maximum amount of current that a conductor can carry without overheating. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. By considering both of these factors, you can ensure that your electrical systems are safe, efficient, and reliable.